Yeah, I think we can start. So they have given you this question. This is 12th April 2019. Again, a very recent question. So they've given you this expression which relates the rate of A and the rate of B, and it's a logarithmic function. So they have asked you that A and B respectively can be. Okay. So I think the basic idea between this reaction is I need to figure out what is the relationship between the rates of A and B, and automatically I will get the stoichiometry coefficient, and then I can figure out what the option could be. All right. So let's first of all uh, kind of solve the equation once. So what I have with me is log base 10 rate of A will be equal to uh, log base 10 rate of B plus 0.3010, which is nothing but log 2. Okay, which is nothing but log 2. So this is the equation that has been given to me. So we need to use some principles of log. The first principle that we are going to use is log A plus log B is log AB. All right. So automatically I can tell you that log 10 2RB equal to log 10 RA. Now we can cancel out the logarithmic functions from both the sides, or you can say that we can take anti-log both the sides. So automatically the log will get cancelled out, and we are left with RA equal to 2RB. So this is the equation that we have got. Now we need to write the, okay, now to predict the what could be the options. So that's what I'm okay. So what we can do is we can say directly say this half RA will be equal to RB. So if this is true, then this will be derived from NA by 2 will be equal to NB. Okay, because by differentiating this moles with respect to time, we get the rate. All right, so I guess the coefficient of rate will not change. From this we can tell you that the coefficient of A will be 2 and the coefficient of B will be 1. So the equation must be some 2A gives B. Alright, so it has to be something like, so if I take, let's just say C option, C option would be C4H8, C4H8, and the A will be twice C2H4. So you can see that the C option satisfied this equation. Alright, so I think the answer should be C. As you can see, let's read the question first. So NO2 required for a reaction is produced by the decomposition of N2O5 in CCl4 as per the equation. Okay, so N2O5 is decomposed into NO2 and O2 in the presence of CCl4. Okay, so CCl4 is probably the catalyst. We have nothing to do with it probably. The initial concentration of N2O5 is 3 mole per liter, and it is 2.75 mole per liter in 30 seconds. All right, the rate of formation of NO2. It's a fairly simple question, again a very recent question. So what we're going to do is we're going to first calculate the rate of decomposition of N2O5, which will be nothing but, so a rate of N2O5 will be change in the concentration. So there is a decrease in the concentration of how much decrease. So initially it was 3 mole and eventually it becomes 2.75. So the change is 0.25 mole per liter divided by time. Time is 30 minutes. Okay, so I'm going to divide it by 30. So this is the rate of decomposition of N2O5. Acha, this will be, so I can just write the rate is using the equation. I can just automatically write that half rate of N2O5 will be equal to 1 by 4 rate of NO2. All right, so okay, so we have got rate of NO2 as twice the rate of N2O5, or you can directly see that this is already in the 2:4 ratio. So NO2 will become twice that of N2O5. Alright, so rate of NO2 will be twice into 0.25 by 30. So it becomes, I think, 0.5 by 30. Yeah, now it's the should be 5 by 300, which is nothing but 1 by 60. 1 by 60 is roughly, I can say that it is, if I take it as 100 by 60 into 10 raised to power minus 2, 100 by 60 is roughly 1.67. So the answer should be B. Alright. Now let's look at the next question. So as you can read in the question, there is a reaction and they have given you the observed rate expression. Okay. So as you all know that for any reaction, the rate law is always experimentally determined. We cannot just read the reaction and directly write the rate law. But we can definitely give some sort of an idea. For example, for elementary reaction, we can write the rate law. And for every other reaction or any complex reaction, the rate law must be given in the question. Otherwise, we cannot write the rate law on our own. So in this question, they have given the reaction and they have given the rate law of the equation. We need to find the rate expression for the reverse reaction. Alright. So first of all, let's figure out whether this is an elementary reaction or not. As you can see, the coefficient of H2 is 2 and the order of the reaction with respect to H2 is 1. Alright, so the coefficient and the order are different. So we can directly tell you that this is not a elementary reaction. Okay, so we need to figure out the rate expression for the reverse reaction. So this is a very peculiar question. So let's write the K equilibrium first. So considering that this is a reversible reaction, so I'm going to write the reaction one more time. So considering that this is a reversible reaction, we can write the K equilibrium as Kf, or I can just write Kf by Kb. This will be equal to N2 active mass of N2 multiplied by H2O square divided by H2 square and NO square. So this is the K expression of K equilibrium. Alright, so we can also write, we can further solve it further and write this as Kf multiplied by H2 square and NO square. This will be equal to Kb N2 into H2O whole square. Alright, so we know that at equilibrium, the rate of forward reaction will be equal to the rate of backward reaction. Alright, so if you look at this expression, what I'm going to do is I'm going to so we have the expression as Kf multiplied by H2 square and NO square, but in the question they have given you Kf multiplied by NO square and H2 square. So I can just write it as Kf into H2 into NO square, and I'm going to write H2 on the other side. Alright. So by looking at the expression, I can say that this is the rate of forward reaction. This is the rate of forward reaction because they have given this in the question. Okay, this is the observed forward rate, so RF, and we know that at equilibrium RF needs to be equal to RB. So this will be the rate expression for the reverse reaction, which is the backward reaction. So this automatically becomes RB. So the answer should be D option. Alright. So I'll tell you the process one more time. So what I did was I figured out the expression for K equilibrium, and then I tried to express it in the form of RF equal to RB, because at equilibrium rate of forward is equal to rate of backward, and at the rate of forward they have already given in the question. So that will be equal to the rate of backward, so the expression that we get as rate of backward reaction will be the answer. Okay, so that's question for you. Hi everyone, I hope I'm audible. We are doing chemical kinetics as of now, so let's look at the first question. This is a previous year question of September 3rd, 2020. Okay, so for the reaction 2A plus 3B plus 3 by 2C gives 3P. So there are three reactants A, B, and C, and they all combine to form product P. Which statement of the following is correct? Okay, so I think this is based on basic stoichiometry law. So let's write the stoichiometry law first with respect to this reaction. So according to the stoichiometry law, it should be moles of A divided by 2 equal to moles of B divided by 3 equal to moles of C divided by 3 by 2. Okay, I'm not including the product P because in this options you can see that they have only mentioned products A, reactants A, B, and C. Okay, so I'm not including the product P. So now what we are going to do is we are going to differentiate this particular equation with respect to time. Alright, so we'll get half dn by dt equal to 1 by 3 dnb by dt equal to 2 by 3 dnc by dt. Alright, now we need to understand which of the following options are fitting the particular equation. Alright, now let's dn by dt will be equal to I'm cross multiplying 2 across the equation, so it should be 2 by 3 dnb by dt equal to 4 by 3 dnc by dt. Okay, so you can see that the correct option is C. So it was a pretty straightforward question. First we wrote the stoichiometry law, and then we differentiated this particular equation with respect to time, and we have got the answer. Pretty standard simple question.